This video will give you a tutorial for how to use DADM to create decision trees in Excel. So to do that, to create a decision tree, we'll start with going to the DADM tab and then click on the Create Decision Tree button. And we get this pop-up window. This window we see only when we first create a tree, and it's got some settings in here that we can change, but once we click OK out of this screen, we cannot go back and change these settings again for this tree. If you really want to change a setting, you'll just have to create a brand new tree. So the first thing here is, where does the tree start? And it defaults to whatever cell you had selected before you clicked on the Create Decision Tree button. So here's just A1, and I usually just leave it at that default, but it can be any cell that you like. Second down here is just below that, this number format setting. And this gives you a couple things that you can use to format the numbers and how they'll appear in your tree. Number of digits after the decimal place, and then formatting numbers with dollar signs and commas. Just a few things here. Sometimes usually we'll use monetary value, so we'll want the dollar signs. And so I'll usually just leave this default as the first one. Sometimes we might not want dollars, we want to do something else, so you can use one of these other ones. What this does is it will format every number in the tree when you create something. You can change the individual number formats later, but you can't change the whole tree. So it's just nice if you know you're going to have a certain format in your tree to just set it right here, and then it makes things easier. Finally, this last piece over here on the right, optimization type, this specifies how DADM will make decisions for decision nodes. So a decision node with two different options that you could choose from. How does DADM know which one to use? Well, it's defined here. So if you choose maximize expected monetary value, then what it will do is choose the branch on the decision node with the highest expected value. If you choose minimize, it will choose the lowest expected value. This last one, minimize expected utility, is not something that we'll use here, but it's a way to incorporate risk aversion in a very specific way. Usually though, we'll just use maximize. So with all that, I'm going to hit OK, and that window goes away and we get this new one. This is a window we see whenever we create a node in the tree. And since we're starting the tree, we have to create the first node to start things off, and so that's what we have here. Again, several options. We first start by selecting what type of node is it. Is it a decision or a probability? Give it a label, and then how many branches come out of that node. So I'm going to start creating a decision tree here just by using a decision node. And for the label, I'll say first decision. And I'll just leave this with 2 branches. Now on the right, we can define labels for the branches, and we can use either cell references if the names are listed in the spreadsheet somewhere, or as what I'll usually do is just type them in directly. So we have first decision and 2 branches, so I need to give 2 labels. So I'll say choice 1 and choice 2. Now we don't have to specify anything here. If we leave it blank, DADM will put in some default values for us, some default labels and values for these other parts. So below the labels are first payoffs and costs on the branches. So this says once you get to this branch, this node in the tree, and you go down one of the branches, is there a value that's associated with that branch that you need to account for? And so again, we can either specify a cell range or cell reference, or directly type the values in. That's what I'll do here. So I'll just say choice 1, say -1, and choice 2 is -2. We can pretend these are costs. So if you make choice 1, you have to pay $1, for example. Choice 2, you have to pay $2. This last piece down here, probabilities on branches, only applies if we have the probability node type selected. Since we have decision selected, we can't do anything here. So if you try and click on these, nothing happens because probabilities don't apply to decision nodes. So we've entered everything we need for our decision node, so I'll click OK. And here is the beginning of our tree. So choice 1, we pay $1. And right now we only have that we pay something here, and this blue number at the end is what you ultimately end up with through a whole path in the tree. Now, it doesn't look very interesting or maybe make a lot of sense right now. We've only got one node, and so only one thing going on here. We'll see what happens with that as we build out the tree next. Then, okay, so notice here that it says best up here right above the branch for choice 1, and just has a little asterisk by choice 2. This is DADM telling us what the best branch is for this decision. So it tells us best because -1 is higher than -2. And really it's comparing these outcomes here, or these values that we face. So this square is a decision node, these diamonds are the end nodes or the value nodes, and this is ultimately where all of the value that we have to account for in our path through the tree from the beginning to the end gets totaled up. So DADM is telling us choice 1 is best, and then we have this -1 down here. So if we click into that cell, and these are all just Excel formulas, there is nothing extra going on other than DADM putting in the stuff for us. These are all formulas we can edit, and what we can see here is that -$1 there is just Excel taking the maximum of B2 and B6, which are the two outcomes here. Okay, so two things here. We see the value of the choice that we would pick is brought up here, so that becomes the value of this node, and we're also explicitly told which branch is best. Okay, let's keep building the tree and add another node. So suppose in this decision, the choice is maybe 2 games of chance to play. So if we choose choice 1, then we need to define, okay, well then what happens? We pay $1 and then what? So I clicked on this node, and whenever you click on a node, you get this menu with several different choices here. I'm going to use the first one here, expand the tree from this node. Click OK, and we have this window again. Now I'm going to define a probability node. So I'll select probability and give it a label. So I said these are 2 games of chance. So I'll say game 1 outcome. How is this game going to turn out? And maybe we're rolling a 6-sided die. So I want to be able to have all 6 of those outcomes here. So I'll change the number of branches to 6. And then I will label these just 1, 2, 3, 4, 5, 6 for the 6 sides of a standard die. And then payoffs or costs. So I'll list these again as well. And suppose that, if we get 1 or 2, we get nothing, so 0 and 0. If we get 3, 4, or 5, we win $2. And if we get 6, we win $5. And then finally, probabilities on the branches. So now that we have a probability node selected, we can put something here. And so we could directly type in, say whatever the probabilities are, if it was 0.2, 0.4, 0.1, etc. I'm not going to do that here, but so I've got 6 different branches, and we're going to assume that we're rolling some dice, and this is a fair. We're using fair dice, and so every side is equally likely. Now, DADM, if you do not give it any probabilities to use, it will just default to using an equal probability on each one, which is exactly what I want here. So I'll just click OK without specifying probabilities, and we can see that DADM has just put in this 16.67 or so percent chance of each one, which is equally likely when you've got 6 different possible outcomes. All right, so we have this new probability node here, and this $1 beneath this game 1 outcome label. If we look at this formula, we can see that it is taking, it's using all these cells and multiplying and adding things together. So first we have B1 times C2, which is B1 is the probability of the side 1 on the die coming up, times C2, which is the value that we would get if we end up at that endpoint of the tree. So this is taking the expected value, also called the probability weighted average, because we're taking the probability of each branch and multiplying it by the value outcome at the end of that branch, and then adding it all together to get our expected value of $1. Now this may just be rounding to $1. If we go look at add some decimals here, we can see, yes, it is actually a little bit less than $1. So remember, just because you see $1 or 0 or something doesn't always necessarily mean that that's what is actually in that cell. You might want to check and see, is it being rounded or not, just in the formatting. So that's what we had here. So we have about 83 cents is our expected value if we pay $1 to play the first game. Okay, so that shows what we do to create a probability node. Now we'll go ahead and let's create a second one here for the second game. And so I'm going to click on that, expand tree from this node. Use a probability node again. Call this game 2 outcome. And we'll say there's just 2 branches for this. So I'll leave that there. So maybe for this game, we're flipping a coin, but it's not a fair coin. So we need to label the 2 outcomes. So we have 2 branches, one for each side of the coin. So we'll say heads and tails. Payoffs and costs on the branches. We'll enter values. And if it comes up heads, say we win $3. If it comes up tails, we lose another $1. And then finally the probabilities. So here I will enter them because I don't want the 2 to be equal. This is not a fair coin. Maybe it's a trick coin. So the probability of heads is, say, 0.4, and the probability of tails is 0.6. Note that you need to enter probabilities like this as a decimal and not as 40% and 60%. Not like this. DADM will not work with that number format, so you need to make sure and use decimals like 0.4 and 0.6. Okay, now we can click OK, and here's our new chance node. And so here we see that our expected value is negative, and I'll add some decimals and see it's actually negative $1.40. And so up here we can see this is still, choice 1 is still the best choice. And if we go and look at this value, we can see that this is the exact same value from here. This 83 cents is the value of the best choice. And so that becomes the value of this decision here because we wouldn't even go down this branch. If we got here, we would choose to make choice 1 because it's got the higher value. And so our value at this point is also 83 cents. We can see for the decision here that it's still taking the maximum of the values of the 2 choices. But now we can see a little bit more of what's happening where, if you remember at the beginning, we just had -1, -1, -2, -2. Now we actually have something calculated here. And so we can see that it's saying, what is the greatest value of the 2 choices if you say you were to make choice 1 and you get this expected value of 83 cents versus if you make choice 2 and you get an expected value of minus $1.40. We can also see what's happening at the end here now. So this is using the sum function in Excel to add up, in this case, just these two values. But what it's going to do is add up all the values along the path in the tree that gets you from the starting point to the end point that you're looking at. So to get to here, I would have had to first choose choice 1 and then roll the dice and number 4 come up, and that would get me here. So what would happen there is when I made choice 1, I paid $1. When 4 came up on the die, then I won $2 for a net of a $1 gain, which is just adding up -1 plus 2. So that's what's happening with those calculations. And again, these are all just either numbers in Excel or Excel formulas. We can edit this if we want. I don't suggest you do that. In fact, I advise against it because you don't want to accidentally change one of these and not realize why your numbers are off. So usually try to avoid making too many changes, but you can always go back and change these values that are entered like this. Say, oh, actually, we win $1 in this case, so I can edit that. You don't need to recreate the tree. You don't need to go and do anything fancy. Just change that cell. I'll change it back. Okay, so that's creating a tree and a little overview of what all of this stuff means. Let's look at those other features we get when we click on a node. So let's see if I click here. So we've seen expand the tree from this node. That's how we created the two chance nodes, probability nodes that come after the decision. We have some other selections we can make here. Copy the subtree, paste the subtree, delete it, or change a node type. So let's go through each of these one by one. And I had selected this node, so I'm going to copy this. So if I want to copy this probability node here, I can do that, hit OK. Now it's copied, and this node turns red to indicate that we've copied it. And I'm going to go paste it just somewhere else. I'll click on here, click paste, and OK. It puts the node there. So pretty much the way that you would expect copy and paste to work. Can also paste it again if we wanted to. I'll just paste another one here, like that. Maybe let's see, just add a decision really quick here to make it something. Okay. And say I copy this now, copy. It's going to copy this entire subtree. So everything from here on down. So now if I paste this one here, paste, we have the whole subtree now copied. So these two are the same. All right. Maybe I didn't want to do this, so let's delete it. If you click on that and then select delete, click OK, you'll get a little are you sure message. You really want to delete the subtree starting from the selected node? Yes, and it goes away. We get back to how we were before we put it there. Okay, now that last feature. So I'm going to click on, so you can click on the red node to essentially unselect it. I'll click on this and click on change node type. So this will turn a decision node into a probability node, or a probability node into a decision node. So you just click on the node, click change node type, hit OK, and our decision changed to a probability. You can see that the formula here now is the expected value formula and not the maximum formula. You can also change it back. So if select the node, select change node type again. Now it's going to toggle it back to a decision. You can see this is back to the max formula. Okay, so I want to show something here. I'm going to delete this. Okay. So remember we had here this second game with a biased coin, 0.4 probability of heads, 0.6 probability of tails. Maybe I accidentally change this to a decision. And I say, whoops, nope, I don't get to control the outcome of the coin. It's a probability. It's because I'm uncertain about it, so I need to change it back to a probability. So just change node type again. Goes back to a circle for probability node. But the probabilities are now 50-50, or 0.5 and 0.5, which is not what we had before. So DADM will not be able to save the probabilities you originally put in. And so if you change a decision to a probability node, it's just going to make each branch equally likely. Just the same way that when we created this the probability node for this first game, I did not enter any of the probabilities in that window. I just left it blank. And so the default, again, was just to make them all equally likely. Okay, so this is a quick overview of how to work with the decision trees in DADM.